Hello everyone, my name is Khushi Kapatel. I am a first year engineering student of CSPIT Charuset. This is my case study video on the topic of real life application of logic gates in home automation of the subject of digital electronics. So let's start the video. So what are logic gates? Logic gates are fundamental building blocks of digital electronic circuit. They perform basic logic function using binary inputs, zeros and ones to produce specific output. Logic gates are essential for decision making process in digital electronics and are widely used in computing and automation. Now we will discuss about types of logic gates. Firstly, we have AND gate. And output of AND gate is 1 only when all input of AND gate is at logic 1. It is also known as all or nothing gate. Then we have OR gate. Um, Output of OR gate is 1 when any of the input of OR gate is at logic 1. It is also known as any or all gate. Then we have NOT gate. It is known as inverter. It inverts the input uh, zeros to ones and ones to zero. If the input of NOT gate is 0, then the output of NOT gate will be 1. These three are basic gates. Any digital electronics logic circuit can be built using these three gates. Now we have two universal gates, NAND gate and NOR gate. NAND gate, it is opposite of AND gate. Output of NAND gate is 0 only if all inputs are 1. Then we have NOR gate, output opposite of OR gate. Output of NOR gate is only 1 when if all inputs are NOR gate at logic 0. Then we have XOR gate. Uh, XOR gates, its output is 1 when inputs are different. When the input are similar, the output of XOR gate will be 0. Then we have XNOR gate, opposite of XOR gate. Output of XNOR gate will be 1 when inputs are similar. So these are the symbols of logic gate. This is AND gate, this is OR gate, this is NOR gate, this is NAND gate, this is NOR gate, this is XOR gate, and this is XNOR gate. So important of logic gates in home automation. Logic gates serves as foundation of smart home automation by enabling device to function based on specific conditions. They help in decision making by processing input like motion, light levels, temperature, and security triggers. And how they enhance automation we will discuss in this video. AND gate in home automation. In a smart home system, AND gate can be used to control device that requires multiple conditions to met before the activation. One practical example is automated lighting control, where the light turns on only when it is dark and someone is present in the room. Input of AND gate will be output of LDR sensor, and out and second input will be output of motion sensor. LDR detects darkness, and it return 1 if it is dark and 0 if it is bright. Then we have motion sensor. If movement is detected, then it will return 1, otherwise it will return 0. And we know the out logic of AND gate. The AND gate requires both input to be high for the output to be high, and if either of the input is low, then the output will be low. So this is the truth table. uh, when uh, when they when there is dark and no one is present in a room, the light will be remains off. When there is dark and motion is detected, then light will be turned on. The real world implementation of the this practical example can be done by microcontroller that reads a sensor input and process them using AND gate. When both conditions are true, the output signal is sent to activate the lights. Now we will see the simulation of AND gate. So this is the simulation of the AND gate. Uh, Here one input is output of LDR sensor, and another is output of motion sensor. The AND gate, when we turn on any of the input, like we turn on LDR, then nothing happens. When we turn on a motion sensor to output 1, then nothing happens. But when we turn on both, then output is high and we can see LED is turned on. Or gate in home automation. In homes or workplace, sudden power failures can cause inconvenience. Additionally, people might need automating lighting when entering to dark rooms such as basements and corridors at night. A system is needed to turn on this emergency light when power fails and motion is detected. The solution can be get by OR gate. Uh, an OR gate is used to control the emergency lighting system. It ensures that light turn on if either the condition is true, 1, the power failure detected, and 2nd, the motion is detected. The light remains off if neither of the condition is occurs. The input of OR gate will be the output of power sensor and motion sensor. For power sensor, it returns 1 when power is fail, and 0 for power available. And for motion sensor, it will return 1 for motion is detected and 0 for no motion detection. The output of OR gate, uh, if either of the condition is true, it will return 1 and the light will turn on. And if neither of the condition will occur, then it will return 0 and light remains off. So this is the truth table. When power is available and no motion is detected, then light will be off. So here is the advantage of this system. It ensures safety during power failures. It ensure automating control, reduce energy waste, enhance security in dark areas. And in the conclusion, the emergency lighting system is essential smart home automation feature. Using an OR gate, we ensure that the light turns on when either power fails or no motion and or motion is detected. This is the simulation of the OR gate. We will see this. This is the circuit in which power failure and motion detection is input of OR gate, and the output will be see through LED. When we will see this, when we turn on power failure, it means power is failed, then light will on. When motion is detected, then light will on, and both condition will occur at the same time, then also light will on. Now, NOT gate in home automation. In a smart home, NOT gate can be used an automatic cooling system where fan turns on when temperature is not in the desired range. The system uses temperature sensor to monitor room temperature and determine whether to activate the fan. If the temperature is within the range, the fan remains off, and if the temperature is above the set of range, the fan will turn on. A NOT gate is used to reverse the logic signal from the temperature sensor. The solution using NOT gate: temperature sensor reads the temperature. If the temperature is within the range, it gives logic 1, which is the inverted by the NOT gate to logic 0. The fan stays off, and if the temperature is not within the range, temperature sensor will return 0 and NOT gate inverts to the 1, and then the fan turn on. This is the truth table of this circuit, and the solution in smart home system. A temperature sensor measures the room temperature. The sensor's output is fed to NOT gate. If the temperature is within the range, NOT gate output 0, keeping the fan off, and if the temperature is outside the range, NOT gate output 1, turning to fan on. This is the circuit of this system. We will simulate this. This is the temperature. In this simulation, temperature sensor output is fed to NOT gate, and when temperature is within the range, it returns 0. Then the output is high and the temperature is not in the range, then it return 1. The NOT will invert the output, and the output will be 0. NAND gate in home automation. In a smart door locking system, security is enhanced by ensuring that door remains locked unless both required conditions are met. This condition could be a correct PIN or password is entered and a valid fingerprint is scanned is provided. Using a NAND gate, the system is designed so that the door remains locked unless both conditions are true. If either of the condition fails, the door remains locked. A working principle of this system is the two input of the NAND gates are PIN password verification. If input is 1 if correct PIN is entered, and otherwise it returns 0. And the fingerprint verification is other input of NAND gate. Its input is 1 if valid fingerprint is detected. The output of NAND gate follows this rule. The output is 0. It means unlocked when both inputs are 1. In all other case, output remains 1. That means the door remains locked. This is the truth table. You can see this, and when both condition A and B are satisfied, then NAND gate gives output 0. That means its door is unlocked. In conclusion, NAND gate based smart door locking system ensure enhanced security by requiring both condition PIN and fingerprint to be satisfied. This is the simulation of NAND gate circuit. We will simulate this. This is the circuit of NAND gate in which first input is PIN entered and another input is fingerprint match. When both input are at logic 1, it means fingerprint is matched and the correct pin is entered, then the output is 0. We can see this, and that means lock the door is unlocked. Otherwise, any condition, the output is 1. That means door is locked. Now, NOR gate in home automation. In a smart home automation system, an emergency shutdown system ensure that electrical appliances are automatically turned off when there is no activity is detected in room and no motion is detected. This prevent energy wastage. The two input in the system can be first motion sensor that detects motion in the room and device activity sensor that detects if any device is being actively used, like TV, fans, lights, etc. Using NOR gate, the system is designed so that the appliances turn off when there is no movement and no device activity. If any activity is detected, the appliances stay on. Now this is the working principle. In these, two input of NOR gates are motion sensor and another is device activity sensor. The motion sensor returns 1 when the motion is detected, and the device activity sensor returns 1 if any device is used currently. uh, if any device is active. The output of NOR gate follows this rule. The output is 1 only when both inputs are 0. That means no motion is detected and no device is currently activated. Then the all started appliances are turned off. This is the truth table. We can see this. Now we will see. When there is no motion and no device activity, the system automatically shut down appliances, and if any activity is detected, the appliances remains on. And in conclusion, a NOR gate based emergency shutdown system ensure that unused appliances are turned off when no movement or no activity is detected. This helps in energy conservation, cost saving, and enhanced safety in home smart home. Now we will see the simulation. This is the circuit. Now we will simulate this. Wait a while. So this is the circuit. In this there is NOR gate and its input are device activating sensor and motion sensor. We will simulate this. When no device activity is detected and no motion is detected, then the NOR gate will return 1. That means the appliances will be turned off. In any other case, output will be 0. That means the appliances will be turned on, remains on. Now, XOR gate in home automation. In a smart home, XOR gate can be used in toggle switches where pressing a switch changes the state of appliances on to off and off to on. This is useful for system where multiple switches control the same device such as lights and fans. Input of the XOR gate will be switch 1 and switch 2. For switch 1, input is 1 where it is pressed, and otherwise it is 0. And similar for switch 2. The logic of XOR gate is if only one switch is on, then the appliances toggle its states, and if both switches are in the same state, both on or both off, then the appliances remains unchanged. This is the truth table. When switch 1 is 0, that means it is not pressed and switch 2 is not pressed, then the state of the appliances is remains no unchanged. That means in there is no change in that the state of the that appliance. When one any of the switch is pressed, that the it opposite that its toggle its state. If the appliance is turned on, then it will be off, and if it is already off, then it will be turned on. And when both is activated, both switch is pressed, then it is the again there is no change. This is the circuit of the XOR gate. We will simulate this. So this is the circuit where the input of XOR gate is switch 1 and switch 2. Where both switch are off, then output is 0. We can see this. Where any of the switch is turned on, then the output is 1. The LED is turned on. And when both switch are turned on, then again we can see output is 0. LED is off. XNOR gate in home automation. In a smart home security system, an XNOR gate can be used to verify identity by matching two inputs, password entered by user and stored password. Access is granted only if both input are matched. If both is corrected or both is incorrected, the input of XNOR gate will be user enter password and store security code. And the logic of XNOR gate will be it is if both input match, both is corrected or both is incorrected, the access is granted. If the input is different, then access is denied. We will see this is the truth table. And this is the circuit of the XNOR gate. We will simulate this. So this is the circuit of XNOR gate. In this there is two input, enter code and security code. When both code matches, then and then the access is granted. In this we do not have IC of XNOR gate. Because of this we used XOR gates IC and noted this its output, and the output of NOT gate is given to LED. We will simulate this. When both is 0, that means both is matched, both input is matched, then the access is granted, and that's why the LED is on. And any of the input we will change input, and now they both are different. That's why the access is denied and the LED is off. And when we turn on both, again it is similar inputs. That's why access is granted and out LED is turned on. So in conclusion, XOR gates are useful for smart toggle switches where pressing any switch toggles an appliance's state, where XNOR gates are ideal for security verification, ensuring only matching candidates allow access. So that is all from my side. Thank you.